Hello everyone, this is Shane. I hope everyone is wonderful. The date of this transmission is 12/26/2016. The title of the video is U.S. Winter Weather Warning and its Influence on North American Tectonic Unrest. The time period of concern is 1/1/17 through 1/11/17, so January 1st of 2017 through January 11th of 2017. Links will be given in the About section of this video. January 1st through 11th, 2017, severe climate event, USA. Record cold to infiltrate the Northwestern U.S. on or about January 1st of 2017, the new year, and work itself into the southwest by 1/4/2017 or January 4th, 2017. Temperatures of well below zero will be encountered in eastern Montana, north and South Dakota, Nebraska, Minnesota, Iowa, and Wisconsin as this weather anomaly moves east. The Southwestern United States will encounter a hard freeze. Pay attention to Southern California and Arizona. The exact details regarding timing are still unclear. What is clear is the certainty of these extreme weather events to come during the above-mentioned time period. An extreme 500 millibar temperature divergence between North America and the northeastern Pacific Ocean will form as this climate shift evolves. This, along with the steep pressure contrast between North America and the northeastern Pacific, will result in heightened tectonic stress on the San Andreas and Cascadian fracture zones, respectively. Please take note of this if you live on or are close to these tectonic fault zones. Many people don't realize that the jet stream is a creation of the magnetic lines of force within the molten core of the Earth. If you want to know the vortices condition of inner Earth, then you want to know what the jet streams are doing. Okay. So there's 4 layers of the Earth, the inner core. You have the inner core, the outer core, the mantle, and the crust, as can be seen here on this diagram. Consequently, there are 4 layers of atmosphere, or 4 jet streams. Okay, so going inside and out, starting at the inner core, you would be at 850 millibars, or 5,000 feet in atmosphere. The outer core, you would be at 700 millibars, 10,000 feet in the atmosphere. The mantle, you would be at 500 millibars, 18,000 feet in atmosphere, and at the Earth's crust, the outer layer of the Earth, you would be at the outer layer, or the jet stream, 300 millibars, 30,000 feet in elevation. That is where jets fly. Okay, also, there's not just 4 jet streams or 4 layers of the Earth. There's 4 extensions to the human body, 2 arms, 2 legs. There's 4 extensions to the Milky Way galaxy that we're in. There are 4 directions. There are 4 elements to reality: earth, fire, water, and air. The theme of 4 will come up in everything that you find if you look close enough and you pay attention. Okay, and I can show you here really quick about what I was talking about with the layers of atmosphere so everybody understands. So when I say 850 millibars, I'm talking about 5,000 feet in elevation. So if you live at sea level, it's 5,000 feet above you. 300 millibars, of course, is 3,000 feet, and that is the jet stream. That's where jets fly at their highest ascent. Okay, here we're looking at the current jet stream at 30,000 feet, and I just want to show everybody this real quick. You see up here where I'm showing you here, this is the Arctic Ocean, and you see the clockwise rotation, or the wind is going around it and on the right, or towards the right. That is high pressure, and whenever there's high pressure in the Arctic Ocean, it drives cold air southward. What you're looking for when you're trying to look into the future with climate and weather, like 10, 15 days out, is you want to know, is it low pressure or high pressure in the Arctic Ocean, especially in the winter? And you also want to know what it's driving into. In other words, high pressure will follow low pressure. You see this low pressure down here in the Southwestern United States? This high pressure here is going to follow this low pressure. So that's what you look for. So now we can look at this current setup and go, okay, now we see that the cold air is going to drive towards this low pressure as we move into the new year of 2017 and beyond. Okay. Now this is Unisys weather, and I will provide the link, like as I stated above, in the about section of this video. This is the current synopsis here, December 26, 2016. You can see right here in the upper right hand corner where I'm showing. And you're looking at the 300 millibar weather plot, which is 30,000 feet up in elevation. You're looking at the jet stream. Wherever you see these yellows and reds, that's the gradient is very much condensed, very high winds. And this is where your weather phenomena on the surface happen. And so I know people can't see here, but this is basically the United States right here. I'm making a big circle here with the cursor. So we can go out 3 days. I'm going to hit 3 days out. So we're going to go to December 29th. By the way, this is the GFS weather model. As you can see up here, GFS, that's Global Forecast Systems. Okay. So, and of course this is a forecast, so it changes a little bit, but we have a good handle on it. At least I do, because of what I just showed you about the high pressure in the Arctic moving towards the low pressure just off the southwest part of the United States. So we're looking at December 29, 2016, and here's the United States, and we're see this weather system starting to come down. We'll go to 5 day, 2 days ahead, so we're looking at December 31st. And boom, you're gonna have some type of split here. You're gonna have a low pressure kind of split off, but still you got cold air driving down. See it's driving down. 7 day, January 2nd. Look at this. So see, now this is, like I said, 30,000 feet up, but you're getting this driving effect here, this cold air. Now let me go to the 500 millibar. 18,000 feet, and show everybody what's going on here. I'm sorry. Here you go. Yeah, see these yellows here? This is higher temperatures up at 18,000 feet, and see these cold blues? These are colder temperatures at 18,000 feet. And it's this temperature anomaly or pressure anomaly too, because this is high pressure over the ocean here, the Pacific, and this is low pressure over North America. And the combination of the two puts a lot of stress on the west coast of the United States here and going up into Canada and around Alaska here. See it here? See the pressure gradient? See that? And we're talking about 18,000 feet, but again, this is mirroring the outer core of the Earth. Okay? What you see up there is going on down there, or what you detect down there is going on up there. And so this is just, we have to be on alert. Everybody has to be on alert of this, and nobody's going to be telling you about this 10, 15 day event of weather and climate, because you just really don't find that out there. The Weather Channel goes up to 7 days. So we're on the 2nd here. Let's go to the 3rd, January 3rd. We're still at 18,000 feet up here. Look at even more. Now the oranges are coming up here into the Gulf of Alaska, and even colder air into North America. And 9 days, January 4th. We're looking here. Now I'm going to go to 850 millibars, so we're going to go to 5,000 feet. So like Sedona, Arizona is 4,000 feet. This is basically going to be right about where Sedona is, and we can get an idea. Look at this cold air. Okay, so we're looking at the 4th here. You see these yellows and greens here in North Dakota and South Dakota? Those are, well, you're looking well below zero. Anything anywhere from 10 below to 20 below, maybe even higher. The wind chills are going to be way up there. But you see these purples infiltrating down here in northern Arizona and almost all the way to Phoenix. That's unheard of. And again, it's going to put a lot of pressure on this fault, or there is pressure on the fault, and that's why the jet stream is setting up this way. We're not quite sure which one pushes the other, or maybe they push each other, kind of both. Like one pushes the other, creates the other, then the other takes form, and it kind of assists the other. But we have to really watch the San Andreas fault and the Cascadia fault. And of course, after that, we have to watch the New Madrid fault. I'm going to go to 10 days here and look at this. It's just continuing. Now we're still, this is 850 millibars. This is 5,000 feet in elevation. So this is the temperature you're going to see basically on the ground. And this is just, it's amazing. It's going to be so cold that you're not going to see a lot of, like this is a big low pressure down here in Southern California and Arizona, which is, there's moisture, but it's going to be so cold that it's not going to snow much. But it will definitely snow in Sedona. It will snow in Phoenix. It will snow in Southern California. There will be hard freeze. It's going to be a big story. The details of how everything unfolds is, that will change a little bit. And so we're not going to get too caught up in like, January 5th is this, but just know that between January 1st of 2017 and January 11th of 2017, these events are going to take place in some type of format. I don't know if there's much more I want to show you real quick. Okay, we're here at the 7-day earthquakes, and you can kind of see that there has been a lot of activity. See here in Alaska, and look at the West Coast, and then even here you got Yellowstone here, you got Mount St. Helens up here, and then you've got the New Madrid over here. So it's kind of interesting. You see how the jet stream is going to kind of form from what we're seeing here with the plates and the earth. You see, if you're paying attention to the plates and the earth, you kind of see that what happens is the jet stream takes its effect from that causality. Everything in the universe is causality. If something happens, it's because of a cause. And so the jet stream forms because of a cause, or the tectonic plates release because of a cause. And the two causes we want to look at again are jet streams, and there's more than one jet stream, there's 4 of them, and of course, earthquakes. So I think this will be good for part 1. I hope everybody enjoyed it. I love you all, and please leave comments if you have any questions, or if you have any information you'd like to share with me, because I'm learning as well. God bless you all. I love you. Bye.